So this is how to solve a related rates problem, and I'm doing the example of the ladder sliding down the building that we mentioned briefly in class today. I've written the steps up here in the upper right, and I'm going to walk you through those steps for this problem. So the first thing you need to do in these problems is identify your known and desired rates of change. So you're told in this problem that the ladder is sliding away from the wall at 2 feet per second. That's a rate of change that we know. And you're asked how fast the top of the ladder is sliding down. That's what we're trying to find. Now, if we were trying to describe how quickly the ladder slid down the wall, we would describe that in feet per second as well. Now, the ladder sliding away from the wall is this quantity here, the change in that, and the ladder sliding down the wall is this quantity here, right? So we need to give those in step 2 variable names. The variable names, you can call them whatever you like. Since this one's going vertically, I'll call it y, and this one's going horizontally, I'll call it x. And then name the rates of change appropriately. So since this ladder is sliding away from the wall at 2 feet per second, that's describing how quickly this x value right here is increasing per second. It's growing by 2 feet per second. So that would be a description of how fast the x is changing with respect to time. Now, anytime you have a rate of change, you need to ask yourself, is this rate of change positive or negative? And the way you know is if the rate of change is positive, the quantity grows. And if the rate of change is negative, the quantity decreases. So if you look at this problem, the ladder is sliding away from the wall, so the x value here is actually going to get larger, so this rate of change is positive. The thing we're looking for is how fast the top of the ladder is sliding down the wall, which is the change in this as time passes. So what we're looking for is dy dt. We know that's going to be in feet per second, and since it's sliding down the wall, the y value as time passes is getting smaller, so that rate of change would come out being negative. All right, so known rate of change, unknown rate of change. So when you move to step 3, it says find a relationship between the dependent variables. And if you remember what we learned about the Leibniz notation, the dependent stuff appears on top of this. So I really want a relationship between the x and the y in the picture so I can get a relationship between the rates of change. So this is a right triangle, x, y, and I know the 13, so that relationship would be the Pythagorean theorem. Now, that's the relationship between the quantities themselves. Step 4 is going to give me the relationship between the rates of change. So to find that, I'm basically going to need to take the derivative of this equation with respect to time. Now notice no time appears in the equation anywhere. So this is basically an implicit differentiation problem because x depends on time and y depends on time. So I'm going to rewrite that like this. And I left my square off my 13 in the Pythagorean theorem. There we go. Okay, so I take the derivative of this term with the chain rule, and that would look like 2 times x of t times x prime of t. And derivative of this with the chain rule, 2 times y of t times y prime of t. And then the derivative of 13 squared, be careful, because 13 squared is just a constant, so that derivative will be 0. If I switch it back to the Leibniz notation, it would look like this. Okay? And then it says substitute appropriately and solve. So what I know in this problem is that the ladder is sliding away at 2 feet per second. So that's my dx dt being 2. I'm going to replace so you get that. So the relationship basically here. So let's say I knew like a specific moment at which I wanted to define the rate of change. Like maybe I wanted to find the rate of change when the ladder was 9 feet from the wall. the base of the ladder. So the ladder then base being 9 feet from the wall gives me an X value that I can actually plug into this to get a specific number. But I would also need a Y value to find that as well. So if I look at the original relationship, which was this Pythagorean theorem, and I plug in that, I can get that Y, so this 169 is 81, so that's 19 and 69 is 78, the square root of that. So that's a number I can simplify, I can find a decimal for it. But if I wanted to find the actual speed at which the ladder is going down the wall, when X is 9, I could plug those numbers into this equation and then solve for dy dt. And that would be negative 36 over 2 times the square root of 78. Now, I can get a decimal for this. I don't have a calculator in my hand, but you see clearly that this is a negative number. Why is that a negative number? Well, like we talked about earlier, this top of the ladder is sliding down the wall. So the y itself is getting smaller. And since the y is getting smaller, that makes this rate of change negative.